So this isn't a recapping video. It's not a refurbishment video. It's not even a teardown video. It's basically a tour and some comments regarding my original Heathkit IM-17 FET multimeter, or voltometer actually. So I've owned this thing since 1972. I purchased it then when, not to date myself, but I was in high school. And I remember purchasing, where I purchased it, it was on West 45th Street in Manhattan, where Heathkit at the time had a brick and mortar store where you could go in and see kits and purchase whichever ones you wanted. And that was if you didn't want to do classic mail order, which really meant back then actually clipping a coupon, writing your name and address, and stuffing it in an envelope with a check. Anyway, so I built this thing, and I've kept it around since then, in the 50-some-odd year, half-century since then. And I've actually, as you'll see, I've kept it in good shape. Except for the label. For some reason, I've never had good luck keeping this label stuck. So I've pretty much given up. But if we open it, I'm not going to give you the full dissertation on the IM-17. There are lots of videos to do that. So I did loosen it out of its case. So I'm going to move the test leads out just to make some room. And yes, it's in good shape. And apart from the fact that I've never abused this thing, and have used it, and occasionally use it whenever I need an analog meter, which is sometimes does come in handy instead of a digital multimeter, it's in good shape. So without further ado, I want to do a few things in this video. First of all, I'll give you a very quick tour of what the back looks like, in particular the rear of the PC board, because this was my first kit ever. So it was really the first thing I ever soldered. And boy, does the back of the PC board show that off for worse. So I thought that would be amusing to watch what I did so poorly back then with my first soldering job. Nevertheless, the thing still works fine. I also want to talk a little bit about if you come across one of these and want one, they're on eBay all the time. They're not that expensive. Or if you're like me, an original owner and have built one, well, congratulations. I'd love to hear from you in the comments, or from anyone else. So without further ado, let's look at the inside. So I'm going to take it out of its case. I already loosened it out of the case, so I don't have to struggle because it's a bit of a pain. Case is just plastic. There's nothing. Case is just plastic. There's nothing interesting in it. And here's the IM-17. Put the case down. If we look at the back, we'll start with the PC board. So this is pretty rotty looking. Many of the solder joints here are pretty ugly. I didn't even bother taking flex off. I don't think that was much of a thing back then. We kind of left the flex on, and I never bothered to clean this up. If you notice, there's a lot of bodge additions and traces and stuff. The traces on this are on these PC boards was very poor quality, so it was really easy to rip off a pad like I did here. And I remember the reason this one ripped off was because when everything connects to this the function switch on the meter. So it's one of these multi-gang Heathkit function switches, and that solders into the PCB. And when I soldered it in, I never soldered it in straight. So it is crooked with respect to the PCB. So the PCB is crooked with respect to everything else and so forth. And that's because I didn't follow the proper technique for soldering such a thing, which is basically, tack one pin, tack another pin, make sure the rest of the thing in behind is totally flat to the PCB, and then solder the other pins. And then later on, when I tried to correct the thing with really poor desoldering techniques, because I didn't have a Hakko FR300, this is what resulted, and that's when I gave up. When this pad separated and I had to bodge it back, I decided, the thing works. I'll just leave it the way it is. Apart from that, the inevitable battery corrosion here happened over the years. Note the meter connections are totally grotty, and so forth. But it works. The only modification that I've ever made to this was in the area, of course, of the batteries. The C-cell holder had gotten corroded, as you would expect, and so I cleaned that up and put in a nice little plastic one with some self-adhesive pads, and that's worked very, very well. It holds it in. Really nice little C-cell battery holder. And then for the 8.4 volt mercury cell, which I do remember having one of, and it lasted forever, but not forever ever. So eventually I replaced it with a 9 volt battery and added a 9 volt battery clip, and then wired the batteries in. You may have noticed there's a sort of diode here that's sort of flapping in the wind. This isn't in circuit. It was because at the time I thought, well, it's a 9 volt battery. It's supposed to be 8.4 volts. Let's put a diode in series with that to drop 0.6 volts, and that'll probably get me close. Well, no. Did it work? Yeah. Was it necessary? Not at all. So I just left it in there and don't use it anymore. So you can certainly use a 9 volt battery on this thing, and it works perfectly fine. You do find that you will have to use the zero adjust to re-zero the meter probably a little more frequently than you thought you might. Apart from that, nothing has changed. Again, I mentioned this is not a recapping video, so I don't plan on updating this at all because it works. So here's like I think a 0.1 1600 volt plastic paper capacitor. Here's another one. There's not a lot of capacitors in here anyway. Of note is you'll notice the can right here, this little transistor. That's the FET, and that's the original FET that came with the kit, as are all these parts, of course, and mine still works. Occasionally, this FET on others has gone bad for a number of reasons, usually because someone overloaded the DC input or possibly the AC input on one of the low scales, and the protection circuit, which is built into this, was not up to the task of protecting the FET. So it is not unusual to see these FETs blown out. And that gets us to the area of, if you come across an IM-17 on eBay and you're interested in it, so here are some of the things which I consider unobtainium and to watch out for. The first and perhaps most obvious thing is the meter. These actually, I've seen these available on eBay as of this video posting. There is actually one of these meter movements available on eBay for about 25 bucks. Is it worth it? I don't know. It's up to you to figure that out. Also to make sure that it works. Pro tip, if you do have a seller send you one of these, make sure that they wrap some wire around the 2 meter terminals, which are here, these sort of threaded studs. Why? Because that in shipping will dampen, will put a damper on the needle swings. Notice this is off, and no matter how much I shake this, the needle isn't moving much. If we were to take the batteries out and turn it on, it would unshort the meter, and you'd see it go all over the place. And so that make sure they do wrap some wire around the terminals, so that in transit the needle doesn't get slammed back and forth. When Heathkit originally shipped the kit, I remember the meter came with a clip, a little steel clip that simply sat between the 2 terminals, and that's how the meter was supplied. But no one ever has that little clip anymore, and so just wrap some bare wire and that'll do the same thing. Speaking of this meter, don't know if you can see it, but there's a crack. There it is. There's a crack running down the face of it up to about here, and I remember putting that crack in. And I remember I was young and I was heartbroken because, oh no, I cracked my meter face. What am I going to do? Life is not worth living anymore. Well, I lived with it all for half a century, and you can hardly see it. It is not worth replacing the meter over. If you are shopping for an IM-17 or a replacement meter movement, or frankly, in fact, for any Heathkit that features this style of meter, here's something else to look out for. Here's, again, the face shot of my IM-17's meter. Note the red AC scales are nice and bright. In fact, they're all nice and bright because it hasn't suffered any abuse. but that may not always be the case. Now, this is less of an issue on the IM-17 as it is on the benchtop meters, but something to look out for. So let's look at a different meter. Here's a snap of a meter. It's the same meter, but this is off of a Heathkit desktop voltmeter with the same meter, but it's being a desktop. It's been exposed to sunlight and just even ambient light for some reason. So you can see that especially the red scales are quite faded. And so that's also something you might want to look out for. Because those things sit on a bench exposed to light, mostly UV light from fluorescence or sunlight, and so the red scales have faded. These have not. Why? Because if this doesn't sit on a bench, this is in a case which is closed. So that keeps all the fading at bay. It also keeps all the components from getting dusty and humidity encrusted. It really helps. So if you're shopping for a replacement meter movement for whatever reason, or even if you're shopping for a complete IM-17, whether it's on eBay or anywhere else, yeah, I thought I'd bring something to your attention, and that is the difference in meter movement. So here is my original IM-17 from 1972 that I built that we've been looking at, and note the meter scales. I'm going to slide over to another IM-17. This one was an eBay acquisition not that long ago, which was listed for, not working for parts. Not that I was looking for parts, but you never know. And it was actually fairly easy to fix, so I did, so now it works just fine. But note the meter scales here, and I'm going to move back to my original one so you can look at the difference. See that one? Now to this other one. Note that here all the scales are much more bunched up towards the top of the meter. In other words, the white space between the red scale and the Heathkit logo is much larger than it is on mine. And I was wondering, why did Heathkit do this? Now, the scales themselves appear to be just exactly the same in terms of their accuracy and where they are in relation to each other in full scale. So there's no electrical or functional difference really, but they are bunched up more. Now, I always wondered why they did that. And well, it must have been a change in supplier, and I'm going to think I know why this happened. And it has to do with the fact that they probably changed the supplier of the meter movement, not the scale, but the meter movement. So look at the dial pointer, the meter pointer, the black pointer. There's a thin part on top which rides along the scales, and that's what you read, and then it twists and becomes fatter all the way down to the bottom of the meter. And that's how most meter needles are constructed. Notice how much of the meter needle here is thin versus thick. Now we go back here and notice that my original meter has a much longer thin part on top and thick part on the bottom. And of course you want the thin part to be the one that rides the scales that you read the scales against for accuracy. So what I suspect happened is they switched to a new meter movement manufacturer who basically threw these pointers, these needles in just the way they are, and Heathkit had to redesign the scale and reprint the scale so they would all match more or less towards the thin part of the meter needle. So something to look at if you're shopping for replacement meter movements or for an entire IM-17. The other thing I wanted to mention about this is these knobs. They're available if yours looks grotty. So, speaking of Heathkit knobs, this is where I digress in the video and talk about Heathkit's design language and the fact that I'm extremely partial to what Heathkit calls their fifth iteration of their design language, which is called New Look. According to Chuck Pinson, who wrote the Heathkit Test Equipment Products book the modern book on vintage Heathkit, there were 6 eras of industrial design, starting with pre-classic, late pre-classic, classic 1, classic 2, new look, and post-new look. And then that was it. So these knobs are the new look of industrial design, and since it's what I grew up with, and the new look design language lasted from 1967 to 1975, that's what I'm extremely partial to. And so you'll find that not only the IM-17, but a lot of the other stuff that I built myself back in the day, such as some of the stuff you see here, as well as acquired recently, will be of the new look design language era. Apart from that, what else is unobtainium? From that, the unobtainium things are perhaps the semiconductors, and there's really only one, and that's the FET. And we'll talk about that next. By the way, here's my original manual for the IM-17. It is a little bit worse for wear, but I've kept all the manual. I've actually carefully kept all the manuals for all of my original kits, and I'm obviously very happy I did that, because not all of them are available either online or from manual reproducers. So let's actually go to the manual, just to take a quick look at the parts list and one or two little things on the schematic as we talk about what parts may be unobtainium. So this is not a scan of my manual. This is one you can get off online. So let's take a quick look here. There's only the good thing is there's only 3 different semiconductors, which is really all that can go wrong here. There is the FET. Note that Heathkit only refers to it as FET, field effect transistor. They don't give you an industry part number. The only thing you have to go by, at least back in the day, was 417140. Not terribly informative, but we'll deal with that in a second. And then a silicon diode, again, no particular appellation here other than a 5727. And then finally, the 4 of 2N3393s. These are basically plain old PNP small transistors, and we'll take a look at them. And these, in fact, are quite available today. I just looked, and Mauser sells them for far less than $1 a piece, and you need 4 of them. So we'll actually take a look at these the substitutions for these parts. The only, as you'll see, the only one which is really would be hard to replace might be this FET. But let's take a look at some substitutions. Fortunately, over the years, a number of cross-reference databases have popped up for Heathkit part numbers, which is a godsend. This is one I use. There's quite a few of them on the interwebs. So here we'll see 417118. We'll start with the 2N3393, and in fact here Heathkit simply calls it out, and it correctly lists it as a 25 volt half amp, NPN transistor. Here's a spare 2N3393 that I happen to have. Notice the flat side is facing us. I'll just see what the little tester says. So yeah, it's just an NPN bipolar transistor. Note the gain, and also note the unusual pinout emitter collector base. In most bipolar transistors with that kind of packaging, the base would be on the middle pin 2, but here it's an unusual pinout. The PC board on the IM-17 does reflect that. Next, we'll look at the silicon diode, which is just listed as that, and that's a 5727. So we scroll way back up here, and here's the 5727. I'll highlight it, and this again is nothing more than a plain old jelly bean silicon diode. They list the 1N4005, which of course is still available, just a 600 volt 1 amp. silicon rectifier. Almost anything will work here that's similar. Finally, we'll look for the one FET that is used in the IM-17, and Heathkit lists that as a 417140. So back down here, keep scrolling, oh, there it is. So what is a 417140? Okay, it's a N-channel JFET. We kind of knew that, but here are the particulars. They list it, the substitute lists it as a 2N4304. Again, 30 volts, 15 milliamps, sometimes in a metal package, but these are also available in domed plastic packages. Let's take a look. Let's just take a quick look at the data sheet. So here is a data sheet for the 2N4304 FET. Obviously, you'd like it in a TO92 package. If you can still find it in a SOT23, you could create a little teeny tiny adapter board, or just tack on leads to it very carefully and turn it into a through hole. Anyway, it's an N-channel FET. As of this video, neither Mauser nor DigiKey have a 2N4304, and NTE Parts Direct appears to be down. So you'll have to find it elsewhere. I did look on eBay. There are a couple of sellers that are selling unit pieces of 2N4304 for 15 to 20 bucks each, which I think is a kind of excessive, unless you really need one. Here's a spec sheet on it. If you choose to go through, Mauser and see if you can create a substitute for it based on the specs, good luck. So right now, I would have to say that the 2N4304 is almost unobtainium. So this is a spare 2N4304. It's actually labeled as such along its edge. Note that it's in the round domed plastic package, which is one of the two package styles that Heathkit actually calls out in the parts pictorial as being possibilities that you may receive in the original kit. The other one, of course, being the classic metal can, which is what I got for mine, which is labeled 417140, which is Heath's part number. Note that in this tester, the second pin, or contact number 2, is away from us. Oh, here we go. Contact. So yeah, it's an N-channel JFET, just like we expect. Note the gate-to-source cutoff voltage that this tester found. If you're curious as to why it's not unheard of to run across IM-17 meters with their input FET blown out, a reading from the schematic is in order. Let's just look at the relevant portion of the schematic and how it attempts to protect against misuse. So here's up here is our FET, our 417140, and it's happily acting as a very high impedance input and very low impedance output to drive the rest of the stuff on the right. So high impedance to everything on the left, very low impedance to everything on the right. And remember, this meter is designed to present on the DC ranges 11 megohms of input impedance. So that's really good, especially for something that's 1972 vintage. Moving on, the only thing which offers protection are 3 components, because if we trace this back, or the input of the FET back here, and you won't see it here, but trust me, let's say you position this, you select the ×1 AC range, and you connect something to the red lead. That's something, the only thing that's in between whatever you connect to the red lead on the times 1 AC range and the input of the FET is this 3.3 meg resistor. That's it. So, but that forms part of the input protection. The rest of the input protection is formed by these two transistors, Q4 and Q5, and we'll zoom into them. Notice they're labeled overload protection, and they're two N3393s. They're basically jelly bean NPN transistors, but notice they're wired in a kind of odd way back to back. Also, their bases are chopped off and going nowhere. So because they're first of all, because their base is chopped off, these will never conduct in the normal fashion. By normal meaning in their linear range or within their saturation range. These should never conduct in that range. Rather, they're taking into Heathkit is using these basically as protection diodes and gambling on the fact that basically each one of these transistors, when it's configured this way, really kind of looks like two back-to-back diodes, each pointing at each other inside each transistor. Fundamentally, that's not what makes up a transistor, but fundamentally it's two PN junctions organized that way. And those PN junctions are not identical. That's why there's a collector side, and that's why there's a distinct emitter side. And that's also why there's two of these transistors. Anyway, the idea being, at some point, if you apply excess voltage here, one of the junctions in one of the transistors will go into its breakdown state first. And by breakdown, I don't mean that the thing will halt and catch fire. No, what happens is in any semiconductor, if you reverse bias it, not just Zener diodes, but any semiconductor, if you reverse bias it enough with enough voltage, it will enter its breakdown range and it will simply start conducting a lot. And so if that happens, you want to limit that current, and that's what that's part of what the 3.3 megohm resistor is there for. So normally in that case, one of the transistors will conduct, and which one depends pretty much on what the polarity of what it is you're overloading the meter with, and basically shunt that current back to the negative, or positive, depending on the state, basically to the other end, to the other probe on the meter, and basically short that, but through the resistor here, which will limit the current, and in any case should prevent the overvoltage from appearing at the gate of Q1 in order to save its ass. C3, quote, acts with R13, the 3.3 meg resistor, as a low-pass filter to prevent AC from reaching the gate of Q1. Anyway, this is all there is in terms of protecting your FET, and so that's why it is not unheard of to have the FET be blown. I've taken care of my IM-17, so I've never overloaded it, not even close. Even when I've measured line voltage with it, I'm careful to be in the right range, which is times 1,000, and it works just fine. This is, by the way, far, far less input protection than is provided by even the cheesiest of modern multimeters that cost more than 20 bucks. I don't know. Most modern multimeters can take a hell of a lot of abuse in that way before they give up the ghost. Back in 1972, well, not so much. The schematic you've been looking at is one that was just pulled from the internet. I actually opened up my manual, my printed manual from 1970 vintage, and looked at the schematic and realized why I didn't want to use that. Here's the same snippet from my printed manual. You see anything interesting about Q5? Well, its emitter arrow is pointing towards the C instead of the E. So that's just obviously a drafting error, which I guess was corrected in later versions of the manual, but it was amusing. Back in the day, Heathkit offered two accessories for use with the IM-17, both of which plugged into the 1/4-inch phono plug or jack like this. one of which was an RF demodulator probe that looked exactly like this one. This is actually from my IT12 or T4 signal tracer, but it's exactly the same probe, except the one Heathkit offered I don't believe had the audio versus RF switch in it. And of course, it was terminated in a phono jack. The only other accessory Heathkit offered for the IM-17 back in the day was this bad boy. This is the Heathkit model 336 high voltage probe, and it was offered specifically for the IM-17. It could also be used with any Heathkit meter that, of course, had a phono jack like this one, and also featured an 11 megohm DC input impedance. And the latter was very, very important because it would only be useful for meters that had an 11 megohm input impedance because of the way this was constructed. This features a 1.09 gigohm giant resistor in here. And so that, with the 11 megohm input resistance, would give you an accurate reading on your DC scale only, and this was only useful on DC volt scale, and this could basically be thought of as a times 100 probe. So whatever voltage you applied to the tip, with respect, of course, to its little ground clip, would be divided by 100 and then fed to the meter. So you might think that means that, well, I'll just put my meter on the 1000 volt max scale DC, and now I can measure up to 100,000 volts with my Heathkit high voltage probe. And you would be wrong. This was only rated to measure up to 30,000 volts. So they did not want you using it with anything higher than that, and it's questionable whether I would even use it with this meter. Because that means that this meter would see a maximum granted of 300 volts, but still. Something else to keep in mind was the IM-17 had the tip of this jack, which of course meant the tip of this, permanently in circuit with the your DC input, your normal DC input lead. So anytime you had some voltage of whatever kind applied here, you could expect to have 100 times voltage present at this tip. So that would mean, in theory, you could have up to 300 volts present here when doing a 30 kilovolt measurement. So you'd want to make sure that this was nowhere near you, or ground, or anywhere else. Interestingly, they did not design it so that it disconnects, so that the phono plug would disconnect the normal input when you plugged it in. It was not designed that way. I acquired this maybe a decade ago or so long after I had the meter, when I was restoring my IO102 oscilloscope, and I wanted to just verify the presence of voltages in excess of 1,000 volts, and it worked fine for that. In hindsight, I would have probably bought a high voltage probe that featured an integrated meter here, so it did not have to connect to anything except ground. The later redesign of the IM-17, which was the IM-5217, actually deleted this phono jack completely. Probably because one reason might be for safety reasons, and the other reason maybe no one cared for the high voltage probe. In any case, those were the only two accessories ever offered for the IM-17.